Hi everyone, let us solve some problems based on pH of buffer solution. First of all, you need to know what is buffer action and buffer solution. If you take any solution and you are adding drops of alkali or acid, some amount of acid to that or alkali to that, its pH doesn't change. The solution resists to change its pH even though you are adding H plus ions or OH ions to that. That action is called buffer action, and the solution which possesses this action is called buffer solution. Basically, we have two types of buffers, acidic buffer and basic buffer. Acidic buffers are acids, mixture of acids and its salt. Basic buffers are bases and its salts. Handerson derived an equation to calculate pH of buffer solution. Either it is acidic buffer or basic buffer. For acidic buffer, the formula is pH equal to log of concentration of salt or mole number of salt divided by acid strength plus pKa. Here pKa can also be written as minus log Ka. In case of calculating pH of basic buffer, the formula is pOH equal to log of salt by base plus pKb. pKb here also can be written as minus log Kb. Here Ka and Kb are the dissociation constants. Okay, so let us solve some example problem. Here I have written. So what is the pH of solution containing 0.15 mole of NH4OH and 0.25 moles of ammonium chloride. Here base and its salt, right? And Kb is also given. So now what it is, a basic buffer, right? It is a basic buffer. So what is the formula? pOH equal to log of salt divided by base minus log Kb. When you substitute the values, log of salt concentration or mole number is here 0.25 divided by what is the base, 0.15 minus log of Kb is given, right, 1.98 into 10 power minus 5. Okay, when you remove these points, you can write or simplify this particular thing like 5 log 5 by 3. So you can write directly log 5 minus log 3 minus minus of minus 5 plus the whole thing is converted into minus 5 plus log of 1.98. When you simplify this log 5 log 3 value is 0.6989 minus 0.4771 plus or plus 5 minus 0.2966, which is equal to 4.9252. This is the pH of this buffer, right? But we have to calculate, sorry, pOH. We have to calculate pH of this buffer, right? So what is the formula for this thing? pH plus pOH equal to pH plus pOH equal to 14. We know that, right? Now pH equal to 14 minus what is pOH? We 4.9252 equal to almost 9. This is the pH of the given buffer. Next example. Another example. What volume of 0.1 molar sodium formate should be added to 50 ml of 0.05 formic acid to make pH 4 buffer solution where pKa formic acid is 3.80. Here you need to observe the data first of all. Here the molarity is given, right? molarity and the volume. You have to find out what is the relation between molarity and volume. If you know the molarity equation, molarity equal to number of moles into 1000 by V, right? You can rewrite number of moles equal to molarity into V by 1000. Okay, so what you have to find out here, the volume of 0.1 mole sodium formate. You can assume it as VML, which is to be added. So you need to calculate in a mixture. What is mixture here? Acidic buffer, sodium formate and formic acid. So first of all you need to calculate number of moles in VML of 0.1 molar sodium formate will be N equal to, molarity is given here, no, 0.1 into V. We need to find out, right? That's why I'm writing V by 1000. In the same way, number of moles in VML of 0.05 molar formic acid equal to 0.05, which is given into V. What is the V here? 50 ml, right? 50 divided by 1000. To substitute in Handerson equation, you can simplify before calculating it. So what is that? That is concentration of salt, that is HCOONA divided by HCOOH, which is acid. That will be 0.1 into V divided by 1000. In the denominator, it will go up, right? Into 1000 by 0.05 into 50. 1000 will cancel. This will become 0.1 into V by 50 into 0.05, 0.25. So when you apply this in Anderson pH equation, what is the Anderson pH equation for acidic buffer? pH equal to pH equal to log of salt by acid, right? Acid. Here Ka is given directly, that is plus pKa, which is 3.8, right? pKa here given is 3.8 and pH is also given, that is 4, right? When you substitute this thing, pH equal to 4 equal to log of, you already calculated this value. What is that? This is the value, right? 0.1 into V divided by 0.25 plus 3.8. This will become, it can be written as 5 square. That implies, which is also log V minus 2 into log 5. That will become log V minus 2 into, what is the log 5 value? 0.6989. Directly I am writing log V equal to 1.5978 when you simplify this. But you need to calculate V, right? V equal to 10 power 1.5978, which can also be simplified as 10.1 into 10 power 0.5978. So this will become 10 into approximately 4, 3.99 something you will take approximately it will 4 and here nearby 40 ml. So this is the answer. You need to add 40 ml of 0.1 molar formic acid to make pH bore buffer here. Okay, let's see another example. Another example, What is the pH of buffer solution which is prepared by adding 10 ml of 0.1 molar acetic acid and 20 ml of sodium acetate, which is 0.1 molar, where pK of acetic acid equal to 4.74. Here, like earlier example, what is given here? The volume and the molarity. You know the relation between that, right? So you need to calculate number of moles of acetic acid, first. CH3COOH. What it will be? Molarity into V by 1000. What is the molarity given? 0.1 into volume is 10 ml divided by 1000. Whereas for number of moles in sodium acetate, what it will be? 0.1, same molarity into 20 ml, volume different here, and by 1000. Okay, when you simplify this thing, you will get CH3COONA. Why I am doing that? Because in the equation, Handerson equation, you will get the salt by acid, right? You will get 0.1 into 10 divided by 0.1 into 20 divided by 0.1 into 10, right? 0. That will become 0.02 by 0.01. When you substitute this values in Handerson equation, what is that? pH equal to log of salt by acid values are 0.02 divided by 0.01, plus here the pK value is directly given, so you can write down directly 74. Okay, now what is the pH value? You will get 4.74. This can be written as 74 plus the whole thing will become log 2, which is equal to 0.3, I guess. 4.74 plus 0.3 equal to 5.04. This is the pH of this acidic buffer. Okay. Another example, a certain buffer solution contains equal concentrations of X minus and HX, that means conjugate base and acid, where Kb of X minus equal to 10 power minus 10. And what is the pH of this buffer? Okay, so here it is given Kb, right? What is B here? X minus anion, that is 10 power minus 10. But we need to know what is Ka, right? Ka of what? Hx. So what is the relation between Ka and Kb? We know that Ka of Hx into Kb of X minus equal to 10 power minus 14. When you substitute Kb value here, what will happen? Ka, that is Hx, equal to 10 power 14 by 10 power 10. That will become 10 power minus 4, right? Now substitute this Ka value in Handerson equation for pH calculation. pH equal to log of salt by acid, right? Minus log Ka. So here it is given that the concentrations of X minus and X are equal. So directly you can write it down, log 1 minus log Ka 10 power minus 4, right? So this implies log 1 equal to 0, right? So minus of minus 4 into log 10, 1, right? Into 1 equal to plus 4. Here the pH of this solution is, buffer solution is plus 4, right?